Okay, today we're finding the inverses. Find an inverse. So what is an inverse? Remember, it's f negative 1. If this is f of x, then f negative 1 is the inverse. And what does the inverse do? It undoes the original. So if I'm doing subtraction of 5, the obvious inverse would be x plus 5, right? Because plus adding 5 undoes subtracting 5. Now remember, the rule said if I hook them together like this, the answer is supposed to be x, right? So check it out. If I put this guy into this one, if I put x plus 5 into here, it's going right there, then x plus 5 minus 5, that would equal x. Well, what if I do it the other way? Remember, it has to work both ways. So if I put this guy into this one, I'd have x minus 5, and then I'm putting it right there where that x is. X minus 5 goes there. Then I'd have to add 5 to that. X minus 5 plus 5, hey, that equals x. That means these guys are inverses of each other. They undo each other. Adding undoes subtracting. Multiplying undoes dividing. What undoes cubing? What do you think? I can hear you thinking. I'll bet you're thinking that. And that's exactly right. Cubes undo cube roots. And cube roots undo cubes, right? Same kind of deal. Fifth roots. Even works for square roots. But you have to restrict the domain. Now this is the only one that's extra special tricky, right? What is the inverse of dividing by x? You'll never believe the answer here. Let me show you. Well, I'll just tell you the answer and then I'll show you how we got it. The answer is actually, this thing is its own inverse. You say, no way. I say, yes way. Check it out. Let's do this. Let's just prove it to you. Right? This has to equal x. Right? No matter what. So, I put a number in here. Doesn't matter what it is. So I'm going to put this one into this one. Right? So what I'm doing is I'm taking 4 and I'm dividing by x. That's what this one says, right? Yes? Okay. So if I put this guy into here, then I'm taking 4 and I'm dividing it by 4 over x. You agree? Now when you divide by a fraction, what happens? You do the reciprocal. You multiply by the reciprocal. So this is really 4 times x over 4 equals x. Boom! And obviously if you put it back in the same formula, it's going to be exactly the same. These guys are inverses. Now that only happens when you're dividing by x. One number, any number, doesn't matter what it is, divided by x only. Not x plus a number or x minus a number. That's different. We'll have to work it out. So let me show you how to work it out. Let's start with one that has more parts to it, eh? How about this guy? What if I had mx plus b, like say 4x minus 7. Ooh. Well, I know the opposite of multiplying by 4 is dividing. And I know the opposite of subtracting 7 is adding 7, right? But if I'm going to find the inverse, I have to be able to follow these rules right here. Switch the x and y, and then solve for y. And you say, what y? I don't see a y. Remember, this is the same thing as saying y equals 4x minus 7. So, switch the x and y. X equals 4y minus 7. That's step 1. Switch the x and y. Now solve for y. What does that mean? I have to move the 7. So I have x plus 7, because if I add 7 over here, I have to add 7 to this side. And then that equals 4 divided by y. And then I need to solve for y. So I divide by 4. So I divide by 4. Now then, we always want it in mx plus b form. So we want it to say something like this, mx plus b. So remember, this is 1. So 1 divided by 4, that's 1/4. of x. That's the slope. The slope is 1/4. And then 7/4 is the y-intercept. That is what y equals, right? This is what y equals. Now, that means it's the inverse. So if I said, hey, this is my problem, what is the inverse? What is the inverse? Well, you would say 1/4 of x plus 7/4. Yeah, cha-ching, we're done. That's the answer. How about that? Find the inverse. What do? We switch the x and y's, and we solved for y. So let's do another one. A tricky one. Something better, I'm sure, huh? Something more fun. Something more fun. All right, so how about one like this? Let's say g of x is the square root of x plus 9. Oh no, the square root of x plus 9. What are we going to do? Well, we're going to find the inverse, g negative 1. That's what we want. What's the formulae? That's what we want. So remember, we have y. This is really y. Y equals this, right? Because g of x is really y. I have to switch the x and y. So x equals the square root of y plus 9. Now, if you remember your Algebra 1, how do you get rid of a radical? Well, you don't multiply. You raise it to the power. So if this is cube root, you'd raise it to the third power. If it was a fourth root, you'd raise it to the fourth power. Since it's a square root, you raise it to the second power. So you have to square both sides. So over here, I get x squared. And over here, these guys, if you remember Algebra 1, they cancel out. Ta-da! So x squared minus 9 is the inverse. But wait a minute. This is a parabola, right? This is a square root graph. So if you look at the graph of this square root, x plus 9, if you remember, 1, 2, 3, 4, 5, 6, 7, 8, 9, way over here. This graph looks like this. Just like this. And so this guy is a parabola, which looks like this. Right? This is not the inverse of that, right? Only half of this is the inverse of that. So you have to restrict the domain. You have to say, well, I'm only using the one side of this parabola. How do I know which side to use? Well, let's look. I know that this is 9, 0. Whoops. Let's use a different color. This one's 9, 0. Negative 9, 0. I'm still doing that. So that means this one has to be 0, negative 9. We got that part right. Remember, you're switching the x and y's. And then this one, if I put 0 in here, if I want to know, hey, what happens when 0 goes in? Square root of 9, 0 plus 9 is 9, square root of 9 is 3. So that's 0, 3. That means this guy is over here crossing at 3, 0, right? That's what it means. And so this is the right side of this graph is the inverse of this guy. Now you say, well, what's going on? Well, what's happening is it's flipping across this line. So everything up here, everything down here has to move up here, right? Everything down here moves up here. Everything down here moves up here, like that, right? Everything over here, if I flip it across the line, it's going to move up here. If I flip it across the line, it's going to move right here. Right, so that's the deal. You're just reflecting across this line. We can prove that it works. Absolutely. That's it. So this is not the answer. X squared minus 9, you have to say only using numbers that are greater than or equal to 0. So this is the domain that you're using whenever you find the inverse. So if I was answering this question, I would say x squared minus 9, but only if x is greater than 0. All right, so you're only using 1/2 of the parabola. That's what this is saying. Remember, x squared minus 9 is a whole parabola, the whole thing. But we're not using the whole parabola. We're only using the right-hand side of the parabola to get this guy. Okay, let's do one more. One more. Okay, what if I had h of x is, what can I have? How about 2 over x plus 3? Oh my goodness! I want to find the inverse. Yes, indeedy. What is the inverse? Now remember, this is a hyperbola. So our inverse has to look the opposite of the hyperbola, right? Where the horizontal asymptote is, and the vertical asymptote is, right? Where those two guys are, they have to be backwards in this one. The horizontal asymptote has to be the vertical asymptote, and the vertical asymptote has to be the horizontal asymptote. That's just the way it works. So, first thing, we know that this is really y equals, so we'll just write it like that. Y equals that. First step, switch the x and y. X equals 2 divided by y plus 3. Now then I have to solve for y. How do I solve for y? Whoops, where's the y? There ain't no y in there. There we go. I have to solve for y. How do I do that? Well, remember, this is a fraction. And we have to get rid of the fraction. So right in here, we're going to insert a step. Get rid of the fraction. Remember how to do that? Math magic. Math magic. You have to multiply by whatever the denominator is. That'll do it. Now 2's on this side, and then x, let's just distribute x times y plus 3 times x. Look at that. That's what's on this side. So I multiplied by the denominator. That makes the fraction go away. The fraction goes away. Now I've got this problem right here. Easy smeezy. Can I get y by itself? Absolutely. I have to subtract 3x. And then I'll have x times y equals 2 minus 3x, right? And then I just have to divide by x. Chiboo, chiboo. So what's the inverse? 2 minus 3x divided by x. You say, I don't believe it. I just don't believe it. It's true. We did it right. We did everything it says to do. Now you can graph this one on your calculator, and you can graph this one on your calculator, and you say, man, it's just all the little hyperbolas all get all tied up. Or you could find 2 or 3 points if you're trying to prove it to yourself. Did I do it right? Right? If you're trying to prove it to yourself, you know that the vertical asymptote of this guy is what makes the bottom equal 0. Well, that would be x equals -3. Right? X equals -3, the vertical asymptote. The horizontal asymptote of this guy is y equals 0. Right? Now, whenever it's the inverse, they have to be switched. These guys have to be switched. Right? Plus, we can find a point on this graph. If you want to find a point, it doesn't matter. You can find any point you want. For example, if I pick, what happens if I put -2 in here? -2 plus 3 would be 2 over 1. -2 goes to 2, right? So, if we did it right, these guys are going to be switched to, when 2 goes in, -2 comes out, right? Let's see. If I put 2 in here, and 2 right here, right? 2 in both places. 3 times 2 would be 6, right? -6. 2 minus 6. 2 minus 6 is -4. 2's on the bottom. -2, hey, hey. When 2 goes in, -2 came out. Check it out. Now, that's not really a proof. What about the horizontal asymptote? Has to be the vertical asymptote. So the vertical asymptote has to be 0. So let's see. What makes the bottom of this equal 0? 0. Easy smeezy. Okay, how about the horizontal asymptote has to be switched to root. It has to be y equals -3. Remember how to find the horizontal asymptote? It's the ratio of these two numbers. -3 divided by 1. Oh my goodness. -3. We did it. We found them all. We found everything and it all works. Perfect. Perfect, perfect, perfect. We just proved it to ourselves that this is the inverse of that. So, that's what we're doing today. Enjoy. Bye-bye.